Joe James, and in this video I'm going to show you how to write a Python program to apply breadth-first search to an undirected graph. Now if you haven't seen my general video yet on breadth-first search, I strongly recommend you go back and watch that first. It'll give you a general idea of how breadth-first search algorithm works. This video is going to focus purely on how to write code to implement a breadth-first search. We're going to use this undirected graph with 10 vertices with letter names A through J. So our breadth-first search program is going to have two classes. It's going to have a vertex class and a graph class. So the vertex class needs 4 different variables. We have a name, which is the letter name of the vertex. We have a list of neighbors, which will store a list of directly connected vertices to this vertex, and it will only store the letter name of the vertex, not the vertex object itself. A distance variable that stores the distance from the source, and color. And then we only have one function, which is add neighbor, and it accepts a letter name of a vertex that will add it to the neighbors list. In our graph class, we need to store all the vertices. We're going to store those in a dictionary object, and we'll explain that in a minute. So we have a function to add a vertex. It takes a vertex object. We'll add it to this vertex dictionary. We have an add edge function that takes the letter name of the vertex at either end of that edge, and then a print graph function and a breadth-first search function. For color, we're just going to use red for visited and black for not visited. Our neighbors is a list of directly connected neighboring vertices to that vertex. So if we look at our graph, we see there is an edge between A and B. So what we want to do is add B as a neighbor to A and add A as a neighbor to B. So this represents all of the edges in the graph. And for vertices, I said we have a dictionary object. We're going to store as the key the letter name of the vertex, and as the value the vertex object itself, so that we can have quick access to the letter name and the object of the vertex. Now let's look at the code. So we have a vertex class, and we have a constructor here that takes a name argument, and we can assign that to self.name. We also set up an empty list for the neighbors, and we set our distance, we initialize it to a high number, and we initialize our color to black, which means that it's unvisited. Then we have an add neighbor function that takes V, which is the letter name of a vertex, and if that vertex is not already in this vertex's neighbors, it will add it to the neighbors list and resort the list, because we always want to store the neighbors as a sorted list. In our graph class, this is our vertices dictionary. So we start out with an empty dictionary for vertices. Our add vertex function takes a vertex object. First we check if this vertex variable passed in is actually a vertex object. So we say, is instance vertex a vertex object? We don't want to accidentally assign a string or some other type of variable to this dictionary. And then we also check to make sure it's not already in vertices. And if it's not, then we'll add it to the vertex dictionary and return true. Otherwise, we'll return false. So to add an edge, we pass in the letter at either end of that edge. First, we verify that both of those are valid vertices in the graph, because if we passed in an edge that includes a letter name that is not a valid vertex in the graph, then we can't add that edge. And if we pass this check, we're going to find the vertex at either end of that edge, and we're going to add the other vertex at the other end of the edge as its neighbor. So we do that here. And then we return true after we're finished adding an edge. Print graph, we simply iterate through the vertices. We print out the name of the vertex and a list of all of its neighbors. Our breadth-first search function needs a starting point, so it takes a vertex object as a starting point. Now, as you may recall, breadth-first search uses a queue to process all the vertices. So we'll start an empty queue, variable named q. We'll set the starting point vertex distance to 0, since the distance from any vertex to itself is going to be 0. And we'll set the starting point vertex color to red, since that's where we're starting, we're already visiting it. Now we'll loop through each of the starting point's neighbors. We'll set its distance to 1, and we'll append those neighbors to this queue. And then one by one, we're going to pop a vertex off of the queue as long as there's still items on the queue. Now, since U is just the letter name of the vertex, we want to get the vertex object. So we'll assign the vertex object to node U. And then we'll set node U's color to red since we're going to visit that vertex. Now we'll iterate node U's neighbors. For each vertex and its neighbors, we want to get first a vertex object since V only gives us the letter name. So we'll use node V to save the vertex object of each neighbor. If that neighbor vertex has not been visited yet, in other words the color is black, then we'll append that neighbor vertex to our queue. And if that neighbor's distance is greater than one more than U's distance from the source, then we can update his distance to node U's distance plus 1. And that does it for the depth first search function. Now let's look over how to use this program. So we use the letter G to assign a new graph object. So there are multiple ways to create a new vertex and add it to the graph. Here's one way. We can say lowercase a is a vertex object with letter name capital A. And then we can add that lowercase a vertex object to the graph. Another way to do it in one single line, g.addVertex, new vertex object with letter name B. So that will add a vertex B to the graph. If we do it this way, we don't actually get a pointer to the vertex B object, as we do here with A. But the quickest way to do it is simply to use a for loop. So we can say for I in range A through K. Mind you, this will only go through J, since that's how the range function works. And then add vertex with that letter name. And we don't have to worry about adding duplicates since we've already checked for that in our add vertex function. Our edges, here's a quick way to add all the edges. We put all these edge names in a list. Here we have an edge from A to B, that's simply a string, and AE is a string. And then we say for edge in this edges list, add edge using the first letter and the second letter. So one by one, these edges will all be added into the neighbors list for each of our vertices. And then we can call breadth first search starting at vertex A as the source, and then we'll print the graph. And by the way, print graph also is going to show our distance from the breadth first search. Now let's see what we get when we run the program. So we can see our print function prints out the letter name of each vertex in order. It prints out the neighbors list of that vertex, and then it also prints out the distance from the source. So the distance from A to itself is 0. Then you can see that node B is a direct neighbor of A, as is E, so they have a distance of 1, and so on. So this shows you the distance of every vertex from this source vertex A. So that concludes my video on breadth first search. I hope this was helpful for you. You can get all the code online here on my GitHub site. And if you like this video, I hope you'll subscribe to my channel. I'm Joe James. Thanks for watching.